Today we're going to look at patterns and nonlinear functions. And so we're going to first start with what is the difference between linear and nonlinear. And so linear functions are something we've talked about in the past, but a linear function is a function whose graph is a non-vertical line, just meaning that the line that's created by our data isn't just straight up and down, or a part of a non-vertical line, meaning that there's not 2 points right on top of each other. We talked about what a function was last time, which is where every x value has only one y value. And so if the line is straight up and down, it means there's multiple y values for each x value. We don't want that to be the case. If it is, if the line is straight up and down, then it's not even a function. But specifically today we're looking at the difference between linear functions and nonlinear functions. And so with linear functions, linear really just means that it forms a straight line. And so we look at our three examples that are there on top next to linear function. A linear function is when a line is formed that isn't straight up and down. And so linear function, straight line. Linear function, straight line. Linear function, straight line. And as long as that line is not vertical, is not just straight up and down, then it's a linear function. Nonlinear function, which is what the graphs that we're looking at today are creating. Nonlinear function is still a function, so it's not just a vertical graph, like the line that's created isn't just like straight up and down. If it's that, it's not a function. But in each of these lines, it's not linear. The line that's created is not just one straight line, and so we have a curve. Or we have absolute value graph right here. And so nonlinear function is a function whose graph is not a line, as opposed to linear that is a line. So a couple of different examples. We're going to look at these two right here as we look at pizza area and cost sauce. So we're going to put each of these onto a graph by simply putting these coordinates on there. So for pizza area, our first coordinate that we have is the coordinate 2 and 12.57. And so on your graph, we go over 2 and we go up 12.57. And we have a point right here for 2, 12.57. And then 4, 50.27, just above 50 right there. And then 6, 113.10. And so we go over to 6 and up to 113. And then we have 8, 201, which is here. Lost my 6 one. And then we have 10 and 314. And as we look at these points that are created and we draw the line for these points, what we're seeing is that it's not going up at a constant rate. Like as we go up by 2 each time in our x value, this amount right here is not the same, right? Like it goes up by 38 right here, and then it goes up by 60, and then it goes up by 80, and then it goes up by over 100. Like it's increasing each time, and the line that's created for that looks like this, where it's not just a straight line, it's not a constant change, it's increasing as we go up. And so for this graph here, it is it is non-linear, right? The line that's created is not a straight line. But then when we graph our sauce and the cost of it, when we go over 2, right, 2 ounces, our cost is 80 cents, and so over 2 into 80 cents there. And then when we go to 4, it's $1.60. So there. Then when we go to 6, it's $2.40. And when we go to 8, it's $3.20. And to 10, it's $4. And as we look at, again, our change, every time as we go up by 2 on our x-axis, we're going up by 80 cents here, right? And we're going up by 80 cents here. And 80 cents here. And throughout this entire thing, it's a constant change. the line that's created is a straight line, and so we have linear function. So nonlinear, not a straight line. The change is not constant in our graphs, right? Our change throughout this is different each time. Linear function creates a straight line, constant change throughout. 80 cents is what we're going up by each time in our graph. So linear versus nonlinear, constant change for linear, not constant change for nonlinear. And then on our graph, creates a straight line for linear, does not create a straight line for nonlinear. Again, another example here, we're asked first to fill in the rest of the table by kind of looking for a pattern. And so as we look at our data, what's the pattern that we find? And so the pattern that we're looking at here to get from 2 to 8, or then from 3 to 27, what's happening each time is that we're taking whatever x is, and we're raising it to the third power, right? 2 times 2 times 2 is 8. 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. And so if we continue that pattern, 4 times 4 times 4 is 64. And 5 times 5 times 5 is 125. And our ordered pairs are just taking our x and y value and putting them into our ordered pair form, which looks like this. So we'd have 4 is our x value, and 64 is our y value. And then when x is 5, y is 125. So what we see again in our pattern is that whatever x is, we raise it to the third power, and that's going to give us our y value. And then we're going to take that information, those ordered pairs, and we're going to place them onto our coordinate plane. And so we have 1, 1, which is right here. We have 2, 8, which is about halfway between 0 and 15. And then we have 3, 27, almost up to 30. And we have 4, 64, which jumps all the way up here above 60. And we have 5, 125, all the way up top here. And then like if we went with 6, it'd go all the way off of our chart. And so we can see if we were to draw our line connecting our dots, it's not straight, it's not constant, it's not going up by the same amount each time, but instead it starts to go up, and it just starts to increasingly go up faster and faster until we get where we're heading off the chart. So this nonlinear doesn't create a straight line, doesn't have a constant change throughout. As we go up by 1 each time, what we're going up by each time here is increasing every single time. So nonlinear in our graph. Last one, again, this is the same thing as before. We're looking for the rule that represents the function. If we wanted to take this and make a table instead of the ordered pairs, if we liked how that looks instead, it's the same thing that we've been doing throughout. We have if x is 1, y is 2, and then if x is 2, y is 4, and if x is 3, then y is 8, and 4, 16, and 5, 32. And so we're looking for the pattern. How do we get from x to y? And so we see that our pattern is that y is equal to 2 to the x power, and so we're taking whatever x is and making that our exponent. So 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8, 2 to the fourth power is 16, 2 to the fifth power is 32. So there's our rule for it. And then once again, this change. Every time we go up 1 here, do we go up by the same amount on this side? We go up 2, then we go up 4, then we go up 8, and then up 16. And so since this change right here is not constant, then what that tells us is that this graph, again, is non-linear, not a constant change, not a straight line. If we were to put it on a coordinate plane, our line wouldn't be straight. So non-linear function.